In this example, we are going to look at how we factor out the greatest common factor. This is going to be a skill that we use quite often anytime we have to do any problem that requires factoring. So when we talk about the greatest common factor, we will all often refer to it as the GCF. So let's take a look at the example problem we have in the 8x plus 14. When we look at 8x plus 14, we should realize that both terms, the 8x and the 14, share a common factor of 2. So essentially what we're doing is we're dividing both terms in the binomial by the GCF, which is 2. Now, when we divide it, we can't just get rid of the 2. The 2 stays as part of our expression for our answer. So what I'm going to do is I'm going to write the GCF of 2, and then I'm going to start a parenthesis with the terms that will be left over in the binomial. So to figure out my binomial, I look at each part of the original binomial where I divided by 2. When I do 8x divided by 2, I get 4x, and then also, when I do 14 divided by 2, I get 7. So I can rewrite that term as 2 times 7. So this isn't my final answer. What I've done so far is I've rewrote each term, the 8x and the 14, as a product of the GCF, which is 2, and some other term. So 2 times 4x plus 2 times 7. Okay, now we're going to write our final answer. So what I notice is that both of these terms share a common factor of 2. So what I'm going to do is I'm going to factor out the 2. So the 2 will go on the outside of the parentheses, and then the 4x plus 7 is the remaining binomial. That will be my final answer. But of course I want to check. So what I'm going to do is I'm going to distribute the 2, and I'm going to see that I end up with the 8x plus 14 that I had in the beginning. So now I know that 2 times 4x plus 7 is my final answer with the GCF of 2 factored out. Let's look at some other sample problems. Okay, in part A, again, we have a GCF of 2. So we're dividing both terms by 2. So we put a 2 on the outside of the parentheses, and then we're left with 3t plus 4. And I encourage you to do the check. Distribute the 2 like I showed you in the example so you can make sure that you arrive back at 6t plus 8 when you're done. All right, let's look at part B. In this case, my GCF is y to the 5th. So what I'm going to do is I'm going to divide both terms by y to the 5th. Now, the reason why my GCF is y to the 5th power is because that's the highest exponent that I can divide both terms by. Now, I said highest, but in a minute I'm going to say smallest, so make sure we keep this straight. Y to the 5th is the highest power of y I can divide both terms by without having to wind up with a negative exponent. But 5 also happens to be the smallest exponent in the original expression. Let's take a look here. So my GCF is y to the 5th. So y to the 5th will go on the outside. Now, in the first term, when I do y to the 5th divided by y to the 5th, it's just 1. Then when I do y to the 7th divided by y to the 5th, I get y squared. So that's what I meant about y to the 5th being the highest power of y I could divide by without having to go into negative exponents. But notice how the 5 is also the smallest power that I saw in the original expression. So your GCF, when your GCF is a variable, the power on that variable will be the smallest power that you saw in the original expression. Let's look at part C. As soon as I see that my leading coefficient is negative, like I have a negative 9 right here, I know that my GCF has to have a negative sign. Then I go through and figure out the rest of it. So they all have a 3 in common, and then the smallest power of a is just a, or a to the 1st. So my GCF is negative 3a. I'm going to rewrite the original expression because I want you to see how we divide everything by negative 3a. So I'm going to divide each term by negative 3a. So for my final answer, I have negative 3a on the outside of the parentheses. Now, when I divide, the negative 9 divided by the negative 3 becomes a positive 3, and a to the 5th over a is just a to the 4th. Then I have a plus 18 divided by a negative 3, so notice how that becomes a negative 6. And then a squared over a is just a. And then the last term becomes positive 1 because it's negative 3a divided by negative 3a. And again, I encourage you to distribute the GCF of negative 3a to make sure we get back to our original expression. And notice how all the signs changed. So all the signs in the black writing, 3a to the fourth minus 6a plus 1, they're all opposites of what they were in the original problem. Let's look at part D. Both terms have a GCF of 6, and also t will be included. So I'm going to divide both terms by 6t. So I put 6t on the outside of my expression. 6 divides by 6 just leaves a 1 behind, so all I do is t to the fourth divided by t, which leaves me t cubed. Then I get minus 2, and no t on that 2 because t divided by t is just 1. So my final answer is 6t times t cubed minus 2. All right, when I have the fraction in part E, it might look confusing at first, but notice how they all have a common denominator of 7. So my GCF is just going to be 1/7. So my GCF is going to be 1/7, and then I need a power of x. So I want the smallest power of x, which is x squared. So on the outside of my expression, I'm going to have 1/7 x squared, and then I'm going to open up a parenthesis. Now, remember, to get back to the original expression, we're distributing the GCF. So in order to get back to 3/7, if I'm distributing 1/7, all I need is the integer 3, because 1/7 times 3 gives me 3/7. And then I need x squared to make up the x to the fourth. In the second term, all I need is 1/7. Since I already have that in the GCF, I just need to multiply by 1x to give me the x cubed. And then in the last term, since I need minus 5/7, but I already have 1/7, I just need minus 5. And since I already have the x squared, I don't need an x in that last term. Now, in the middle right there, that 1x, you don't need the 1. You could have just wrote plus x. But again, I encourage you to distribute that GCF to make sure you understand why we will get back to our original answer and why this is the correct factorization. All right, in part F, I noticed that all three terms share a common factor of 5, and then I want the smallest power of each variable, so it'll be 5p squared q cubed. I'm going to rewrite the original expression again so we can see the division. So I'm going to divide each term by 5p squared q cubed. And then when I write my final answer, I'm going to put my GCF on the outside, and then I'm going to put the leftovers. So 15/5 is 3. P squared divides by p squared and just leaves 1 behind, so I don't need to write it in this case because I already have the 3 there. And then q to the fourth over q cubed is just q. In the second term, I'm going to get plus 4. And then there's going to be p, just plain old p, because it was p cubed over p squared, and then q squared. Now in the last term, 5 divided by 5 is 1, but I don't have to write the 1. P cubed over p squared is just p, and then the q cubed divided by q cubed is 1, so I don't need to write that either. And again, I really encourage you to distribute on your own note sheet and just make sure you see how we get back to the original expression.